You know that feeling, right? The app hangs, the website freezes, that little progress bar just spins and spins forever. Well, that's not just a glitch, it's actually a ghost. It's a ghost of a decision an architect made, maybe months or even years ago. Building applications that are fast, reliable, and just feel good to use is a really high-stakes gamble. So today, we're going to pull back the curtain on the two core strategies that decide whether your system can handle the pressure or if it just shatters when things get tough. So here's our game plan. We'll kick things off with what I call the architect's gamble to really set the stage. Then we'll dive into the core philosophies, waiter versus pager. After that, we'll see it all in action in a case study, the Bookstore Dominoes. Then we'll peek inside the smart mailroom to see how the magic happens, see how it helps us scale with grace. And finally, we'll wrap it all up with your very own strategic toolkit. All right, first up, the architect's gamble. We're starting with the one problem every single one of us has felt, that slow, hanging, frustrating application. We're going to talk about the real cost of building a system that's designed to break, and why making our users wait is a sign of a much, much deeper issue. This quote just nails it, doesn't it? When a user is waiting, it's not just a little bit of inconvenience. It's a straight-up failure of the architecture. It's a flashing neon sign that says your system is fragile, it's inefficient, and honestly, it's creating frustration. And in today's world, that frustration leads right to abandoned shopping carts, uninstalled apps, and lost business. The stakes are just incredibly high. Okay, so this slide really lays out the two paths you can go down. On the left, you've got a brittle architecture. Tightly coupled means all your services are connected like mountain climbers, roped together. If one of them slips, they're all going down. That leads to cascading failures, where one tiny problem can crash the whole show. And the user feels this directly. They have to wait for everything. On the right, that's the goal, a resilient architecture. Its services are decoupled, they operate independently, it's fault-tolerant, so it can handle problems gracefully, and for the user, the experience is night and day. They wait for almost nothing, because tasks are just happening in the background. This is the choice we have to make. So how do we build that resilient system? Well, first, we have to understand the two main ways our services can talk to each other. You can think of it as the difference between having a personal waiter who never leaves your table versus getting one of those little restaurant pagers that buzzes when you're needed. This table breaks it down perfectly. On the left, you have synchronous communication. The best analogy is a live phone call. When you ask a question, you stop, you wait, you can't do anything else until you get an answer. Now, this is great when a user absolutely needs an immediate response, like when they're logging in. Now, contrast that with the right side, asynchronous. Think of this like dropping a letter in a mailbox. You send your message and you immediately walk away. You trust the system to deliver it. This is perfect for background tasks, and its secret weapon is this awesome concept we're going to get into called temporal decoupling. Now, let's really lean into that waiter analogy for a second. Imagine you're at a super busy restaurant. The waiter comes to your table, but you're not quite ready to order, so he just stands there, pen poised, waiting. He can't go take another order, he can't get drinks for someone else, he can't clear a table, his entire capacity, his ability to do work is completely blocked, just waiting for you. That is a synchronous system. It ties up precious server resources, memory, threads, connections, just waiting. It's a huge waste, and it's why systems fall apart under heavy traffic. And this brings us to the magic trick, the whole point of going asynchronous. It's called temporal decoupling. This is basically a superpower. It means one part of your system can send a message without knowing or even caring if the other part is online or busy or has temporarily crashed. The system's infrastructure, the mailroom, guarantees that letter will be kept safe until the recipient is ready for it. This is what lets everything keep flowing no matter what. Okay, enough theory. Let's see how this stuff actually works in the real world. We're going to walk through the checkout process for an online bookstore. And this is a fantastic example of a hybrid approach using both synchronous and asynchronous communication, where each one works best. All right, let's follow an order and pay really close attention to the parentheses. Step 1, you click place order. That's a synchronous HTTP call. You need to know it went through. Steps 2 and 3 are also HTTP, creating the order and giving you that confirmation. You, the user, are waiting for that. But look at step 4, recording this action for auditing. Does the user need to wait for that? Absolutely not. So we fire off an asynchronous AMQP message, our letter to the mailroom, and just move on. Then it's back to synchronous HTTP for the shipping steps to update your screen. It's this clever mix that gives you a snappy experience and a super reliable backend. So this flow looks great when everything's working perfectly. But the real test of an architecture isn't what happens on a sunny day, right? It's how it handles failure. What happens when one of these dominoes tips over? And this is where that asynchronous design really shines. Look at how it handles every outcome. If everything works, simple. One fire and forget message goes to the activity log. Done. If shipping fails later on, two separate messages get sent, one to the log saying we tried, and another to an error queue for an engineer to look at. And if the whole order fails right at the start, a single message is broadcast to both the log and the error handler. The point is, no matter what happens, we have a guaranteed audit trail, and we did it all without making the user wait. Okay, I want you to really lock in on this because it's the most important takeaway of this whole thing. Step 4, making that logging call asynchronous, that is the system safety valve. It fundamentally separates the act of making money from the act of recording it. Because we chose to send a message instead of making a direct call, we have guaranteed, that a slow or completely broken logging service can never stop a customer from buying a book. The main business is shielded from failures in the side quests. That is how you design for resilience. So, we've decided we want this letter in a mailbox system. This needs a central post office, what we call a message broker. But just having the building isn't enough. We need a smart mailroom inside that knows how to sort every single piece of mail. This is the job of something called an exchange. Let's look at the 3 main ways an exchange can do its job. First up is the direct exchange. This is the simplest and most precise one. It works just like sending a letter to a specific P.O. box. The message has a routing key. Think of that as the box number. The exchange looks at the binding key of all the mailboxes or queues it's connected to. If there's an exact match, boom, the message goes right there. It's a perfect one-to-one delivery. So a perfect example is something like this. Send this print job to this specific printer. You need to deliver one message to one and only one place. There's no guesswork, no copies. It's the best choice for any kind of direct command. Next, we've got the total opposite, the Fanout exchange. This is the town crier of the mailroom. It doesn't care about addresses or keys at all. It takes every single message it gets and shouts a copy to every single queue connected to it. It's a pure broadcast. And this is absolutely crucial for system-wide alerts. Things where you have to make sure everyone gets the message at the same time. Think about a global cache reset or a tornado warning. When the message is for everybody, you use a Fanout. And finally, we have the most flexible and powerful of the bunch, the topic exchange. This one works like a really sophisticated magazine subscription service. It doesn't look for exact matches, it uses pattern matching with wildcards. You can subscribe to whole categories of information. The star matches exactly one word, and the hash matches 0 or more words. And this example really shows you the power here. A queue could subscribe to truck.star.engine. It would get messages for engine events from truck number 1 and truck number 2, but it would completely ignore tire events. This lets us build really powerful listeners. For example, we could have one single queue that subscribes to star.error, and it would catch every single error message from every service in our entire system. It's just incredibly useful. All right, now for the really cool part, the payoff. We've gone with an asynchronous approach. We've designed the smart mailroom. So what do we get for all this work? Well, it turns out we get an almost effortless way to handle massive growth when our app suddenly gets popular. So let's say our activity logging queue starts getting backed up. There are just too many messages. The solution is just beautifully simple. We just add more workers, more consumer instances, to listen to that exact same queue. We can go from 1 worker to 3 or 5 or 50. And when we do that, the system just takes care of the rest. The message broker automatically turns into a load balancer. As new messages come in, it just deals them out like a deck of cards to all the available workers. It uses a method called round robin. As you see here, message 1 goes to consumer 1, 2 goes to 2, 3 goes to 3, and when it gets to the end, it just loops back around. This makes sure no one worker gets buried in tasks, and it just works right out of the box. And the punchline is, you get this for free. This is not something you have to go out and buy or configure. You don't need complicated, expensive load balancing hardware. The messaging system itself handles the scaling and the workload distribution for you. It's an incredible strategic advantage that lets your system grow without breaking a sweat. All right, let's bring it all home and pack your strategic toolkit. These are the core ideas that get you that snappy UI and that resilient, scalable system we've been talking about from the very beginning. So let's do a quick knowledge check. Can you explain temporal decoupling? Remember, that's the superpower that lets parts of your system talk without being online at the same time. Do you get the role of the broker? That's our central post office. Can you tell the difference between an exchange and a queue? The exchange is the smart sorting room. The queue is the actual mailbox. And finally, do you know how Round Robin helps you scale? That's the broker's built-in, fair way of handing out work. If you've got these, you've got the foundation. So the next time you're designing a new feature or a whole new system, just ask yourself this one simple question about every single interaction. Does this need an immediate, blocking answer like a live phone call? Or can we just drop a letter in the mailbox and trust the system to handle it when it's ready? Your users, your servers, and your future self will thank you for making the right choice.